Hello guys. In this tutorial we are going to see how to use the author's policies to build a workflow. So whenever the authors give their own models like the LLM models, they can also give their own pre and post processing policies. In this tutorial we are going to see how to use those policies as part of the block, the LLM block, and also we will be seeing how by creating some fire and die kind of policies in the post-processing policy, uh, we can also use the LLMs to call these policies like a tool call. So in this tutorial, the overview is like we will have a we'll give a high-level task explanation first, and we'll give a high-level overview about the architecture, like how the policies and other things are composed. And we will also see about how the block is deployed to, which includes the author's pre and post processing policies. Then we will also see about how the policies code are constructed, and we will also do give a high level the LLM models inference code, and then we will also run this pipeline by an inference request, and then the conclusion. So the task in this tutorial that we are gonna automate is like a recruitment automation task. So given a set of PDF files in a zip file, we will extract the content of each PDF file. We'll pass it to the LLM to analyze and give us the matching candidates. And the tools are nothing but a background check tool and the mail intimation tool. So this is the task, and we will see how we are going to implement this as a workflow. So before we start, in general, we should know what are policies in AOS v1. A policy is nothing but it is a dynamically loadable, executable Python code, a piece of Python code, and it is used across different parts of the AOS ecosystem. For more information on this policy, I request you to check this particular link. It has a good overview. It describes about different types of policies and how the and for which scenario we have to use what kind of policy also will be understood from here. And in this tutorial, we'll be using two kinds of policies. One is type 1 policy and another is type 3 policy, which I will explain as we go. And so basically the tool calling that the LLM model will use, right? So that is implemented as a fire and die, the type 3 policies. And this will be called as part of the type 1's post-processing policy. I will explain this with proper JSON structure. It will be easy to understand there. And so the whole flow diagram comes like this, right? So the input is a zip file of resumes, and we will pass that to the blocks pre-processing policy. Remember, we are in this tutorial, we are gonna do an inference for the block, and the block will have its own pre-processing policy and post-processing policy, which is suggested by the author, maybe because the LLM model is specifically trained for this kind of tasks, right? That's a possibility. So we are going to use the author's pre-processing policy, and then the output of the pre-processing policy will go to the LLM model, and LLM model will do the inference, and its output will go to the block level post-processing policy, and the post-processing policy will initiate the calls for the tools, right? So that's what we have explained here. And in case if you are interested in only your own policies and you don't want to use the author's policies, or you want to have something like a swappable policy, or in addition to the author's policies, you want to have your own policies, I request you to refer this tutorial. It will talk about how these policies are swappable when you're running it as a VDAG kind of scenarios. Okay. So in this tutorial, again, it is important to understand we are gonna deploy a block, and we are gonna do inference on the block. So here, if you see, if you have taken the other tutorials, we have something called allocation JSONs, which is responsible for deploying the particular block that we are interested in, and uh, and that contains more details like which node, which cluster it has to deploy, which GPU it has to deploy, and all. But what I want to bring your attention is to this specific area. So here you can see we are describing something called, under the policy rule spec, we are describing a pre-processing block, pre-processing policy. So here you can see the policy rule URI is recruitment pre-processing 100 stable. We have already registered this policy. It can be found in other tutorials. I will also add it as part of this tutorial. And we also have a post-processing policy, which is nothing but recruitment post-processing 100 stable, right? So let me just show the actual JSON file here. So here, if you see, I'm giving the actual system message goes like this. You are an expert recruitment assistant. Your task is to analyze the provided resume context because it's a recruitment related use case, and create a JSON based execution plan for a multi-stage recruitment pipeline. And also, if you see here, I'm also giving the necessary tools. So one is the background check policy, and I'm giving the policy URI and other details here. And another is the send email policy, and for that also I'm giving the policy URI, so that the LLM is expected to refer this particular system message and give the necessary JSON structure at the end, right? So, and I'm also saying, in case of multiple valid candidates, it has to combine all candidates in a single background call, and so that it is easy to instead of calling the fire and die policies for each person, it will be called at one stretch. And I'm also defining other parameters for the model. And as you can see, and as I was explaining here, the pre-processing contains the recruitment pre-processing, and the post-processing contains the recruitment post-processing. These policies are in addition to the usual policies that we have, like cluster selector, resource allocator, load balancer, and all. So since this policy is defined within the allocation JSON of the block, so basically this policy is restricted to the blocks. It is part of the blocks pre-processing and post-processing. So based on the author's pre-processing and post-processing policies, it will be attached here, and we can also pass the parameter settings, right? Now let's move on to understanding the actual policies code and the LLM inference code as well. So we will be adding the policies as part of this tutorial, but I'll just give you a high-level overview here. So first of all, in the pre-processing policy, what we are basically doing is we are using, of course, you can use your own libraries, but what we are doing here is using the zip file to basically unzip the content of the zip file and reading each and every PDF and then reading its content. So that's all we are doing in the pre-processing policy. So what, and of course, we will towards the end, how the LLM will get this data is, it will get it as part of this supplement data keyword as a key in the dictionary, and it will have the file name key and also the content key. So the LLM has to refer to these this particular supplement data, and so this is what we are doing in the pre-processing policy. You guys can try your other libraries, like there is a library called PDF Plumber, or if you want something like LangChain kind of things also, that is possible. So all we have to do is, once we have the policy in place, we need to register those policies in a certain endpoint, and we need to zip it and upload it to a location, right? So those commands also we will share it. And if you have taken other tutorials, you will understand like this is just a basic REST API call. And also in the post-processing policy, what we are gonna do is, before we go to the post-processing policy, let's understand sometimes it is possible that the LLM doesn't give a proper JSON structure, right? So we have to make sure, or the LLM can give more text data apart from the JSON, right? So we have to make sure that we extract the necessary JSON. So what is the role of the LLM here? The LLM's role is to get these particular content from the pre-processing policy, and we will pass certain query like we want the LLM to choose the best candidate with certain qualifications, right, as part of the query from the attached set of resumes. So we want the LLM to decide the next set of tool calls also. So that's the part of the LLM which will come to it. But in the post-processing policy, what we are going to do is we are simply, of course, we are simply in the post-processing policy, we will do a extraction of JSON first of all from the LLM response. We will also do this in the LLM block, but as a safety measure, we will also do it here. And also so how the post-processing policy is implemented is like this. Let me show it here. So basically, we have three important functions, right? So one is to extract the JSON and also to submit and monitor the job. So the policies that we are discussing, are the tools that we are discussing, right? They are part of AOS's type 3 kind of policies, where given a request, it will do the inference and then it will die, right? So those are the type of policies we are interested in. I will give an overview of how we are gonna call and get the response. And this is our main eval function, right? So the eval function receives the LLM's data, LLM's response, and here we are extracting the JSON from the LLM's response in case there is any error in the raw text, and then we will do a tool call. So here you can see, so in this tutorial we have kept it empty, but we will basically performing a tool call by calling this submit and monitor job. So what will happen here in the submit and monitor job is we will have certain tools, right? So in this tutorial, the two tools are background check policy tool and send email tool, right? So once the background check is done for the real candidates, we will send the email intimation. So here what we are doing in the submit and monitor job is, so we will be referring each of these fire and die policies, right, via this policy rule URI. And of course, we will have its job name and parameters, which also I will show in the logs of the in the KH dashboard. So here we will do as a post request to this certain endpoint for the policy rule URI. So this is the job endpoint, and we will submit this particular payload with the job name and the policy rule URI. And what we will get, since these are asynchronous calls, we will get something called a job ID from the response, and we have to poll these particular jobs. So here I'm polling this particular job ID, right? So here you can see I'm doing a request.get, and I'm having a timeout, and I'm checking for the response of 200 seconds. I'm checking whether the response status code is 200. And then if it is 200, then it means that we have got a valid response, and we will then parse and understand its structure, right? And we'll get the necessary output from the tools that we want, and we can also pass this output to the next tool also, right? So those kind of things can be taken care here. So the important thing to understand here is the concept of polling these asynchronous requests. So this is the high-level implementation of the post-processing policies. So to conclude this post-processing policy, it takes care of calling the background check and the send email type 3 policies by using a asynchronous request and polling structure, right? Now let's understand about the LLM context code. So if you guys are new to this, I would request you to check this particular tutorial, where it will contain details about how the model inference code is implemented. I will just give the necessary context, necessary code here, where it will use the pre-processing's output as part of the LLM's message, right? So here you can see we are checking for this particular supplemental data key. So we are expecting this data key to be present as part of the pre-processing output, and we are checking for the candidates data. So we will get the candidates data from the LLM. We will get the candidates data from the pre-processing policy. And what we are doing is we are basically looping through each of the candidates and creating a good formatted context message for the LLM. So once we construct the supplemental context, and of course we can delete the old data, and here we are constructing the final message. So the final message contains this supplemental context along with the user request, the actual message. So the actual message can be the recruitment criteria that the user want, right? So so we are just appending the text along with the user request. So this final message will go as input to the LLM model, right? So again, we can keep things generic here. That's why we have kept a supplemental data. We can also pass the entire candidates data to the LLM model also. So that way we can, the model is generic and it can do any task. It need not be only recruitment automation task, right? So this is the LLM part of the code, and now we are gonna do an actual inference request. So let me just check whether we have covered. So in the inference request part, I'm gonna show how we are gonna do this inference. So I have already deployed the block, this particular. I've basically used this particular allocation JSON, right? And I have already deployed this particular model. So let me show that as well. So here you can see the model is already up, and it is up for around 34 minutes. And the health, the success status is true, meaning it is also available now. So let me do an inference. For the inference part, we are going to supply this particular resume compressed.zip file containing all the resumes, and we are basically going to read this file in binary format, encode it as base64, and I'll show how to construct the payload. That's the crucial part, and we'll show how to perform the request. And so first of all, we have some helper codes here which you can use to do a gRPC level inference. So let me run this. Yeah, so I have all the necessary things, necessary libraries imported. So in the so this is the inference code. So here I'm for now I have added the zip file path, the resume compressed.zip. So all these files are present in the same Jupyter Notebook location, and here I'm using this particular server address. You will be given own other server address as well, and I'm basically passing the this particular request, and how we are constructing the payload is like this, right? So here we have a chat mode in the LLM inference. They have different mode here, like embedding mode, token mode, chat mode, and all. So here we are using the chat mode, and the message that we pass to this function is passed here, and the generation config, right? So how much tokens to generate at max, what is the temperature, and all controlled via here. And I'm passing the file like this. So here you can see I'm basically reading the zip file as normal binary content here, and I'm passing this in the file data as part of this service PB2 library. And I'm also passing the file name here as a zip file path, and also the size, and then we are using that stub to do an inference, right? So let me just load this function. Now with respect to constructing the prompt, right? So this is the generation config I have. So the temperature is 0.1 and the top P is 0.95. I'm giving the maximum tokens to generate as 4096. And the recruitment prompt goes like this. We are hiring for a senior computer vision engineer. Requirements include 6+ years of hands-on experience in computer vision and deep learning, production level experience with frameworks like PyTorch and all, and master's degree or a PhD degree is what a basic requirement is. And we are also saying the LLM has to analyze the provided resumes and create a recruitment plan that initiates background check for qualified candidates and sends appropriate follow-up communication, right? So let me also run this and keep. Now let's do the actual inference. So for this run inference function, we are passing the block ID and session ID. So let me keep some other random session 6, and sequence number is 1, and I'm passing this particular recruitment prompt and also the generation config, right? So I also have the KH dashboard open here. I have kept the llama 4 logs. You can see the model is loaded and waiting, right? And even before the inference, let me just show you that it has loaded the pre-processing policy, recruitment pre-processing, and also the recruitment post-processing policy, right? So again, they are uploaded into certain locations, which is what we are using, right? Yeah, let me do the inference. What's going on? Yeah, I'm changing the ID to, let's say, 7. Let's see. Yeah, we got the response. And our pre-processing policy is basically extracting the contents from the resumes. That's why you are seeing PDF miner, all these content, the text to construct the pre-processing output, right? Yeah, here you can see that we have data like the constructed output from the PDF output. Let me show that in a second. Yeah, so the LLM has given its response, right? So the pre-processing policy has constructed the PDF of have extracted the contents of the PDF. It has composed a JSON file, and it contains the, for each file name, it has its content that is passed as input to the LLM. So the LLM is giving a reply like this. Based on the provided resumes and job requirements, I've identified the qualified candidates, and it has given the next steps also. So out of the 5 resumes we have kept, it is selected 4 out of them, and it is giving the execution plan under the tool calls. So the first tool call is related to generic background check, right? This is what we have already registered, and we are passing this information to the LLM as part of the system message. You can find this system message also here, right? You can see the policy URI here, right? So the LLM understands that it needs to use the background tooling first, and then do the, say, email. And here you can see for the 4 candidates that it has selected, it is also saying what is their ID and what is their name and what is the email, right? For now, for easy demo, I have added my email IDs. And as part of the tooling structure, it is also saying send a follow-up mail, and the policy rule URI for that is generic send email on OOS table. And this particular policy requires 2 inputs, subject and body, and that is also is getting passed. And again, these all are constructed by the LLM itself. And it is also giving some explanation, and it is also saying that the Aditya Sharma is not included in the background check batch as he has less than 6 years of hands-on experience. So the LLM, I mean, of course, we can fine-tune the prompt and all to give a bit more refined selection from the LLMs. But so here we mainly want to show how the tool calling is happening here, right? So once its response is given, then in the post-processing policy, we are extracting. We also extract the JSON in the model's inference code, and we also doing another check in the post-processing policy, right? So here the post-processing policy starts, and it understands what it has to call, right? So here you can see successfully passed LLM response string as JSON. So the post-processing policy starts here, and it has the necessary tool calls, right? Those information. You can see basically the tool call is parsed, and using the the asynchronous URLs. Here we are doing the actual tool call. So the first tool call is related to the background check batch. So here you can see that the results are coming like this. That this particular candidate Anjali Rao, it is considered as status real, and similarly the Priya Singh is also is considered as fake. Like that, it does a background check and then conclude on the actual the realness of the profile, and then it goes on to the second tool call here, and it is sending the follow-up mail to Anjali Rao and Rohan Mehta, right? And I will also show the email here. So actually this concludes the post-processing step. Here you can see that it is polling for the job, and it is waiting till the job is completed successfully, right? So these are the four polling things that's happening for checking the status of the email. And then once it is succeeded, we also have that final summary, which also, right, which I can, the final summary we can have whatever we want, but in this case, it will be a generic information like the recruitment pipeline process finished, background check is done, and the processed number of processed tool calls also mentioned here. So let me show the mail also. So here you can see that it has received the mails. So I'm recording this around 1:38. So you can see that it has got the mail notification. Thank you for your application. We will be in touch with the next steps shortly. And since there are two candidates, it sent two mails. Unfortunately, like the mail ID of both of them is same, right? So that's pretty much on this tutorial. That's pretty much on this tutorial. We have showcased how given a set of PDFs containing the resumes of each individual, how the pre-processing policy extracts the text from all the 5 resumes, and how the inference code, right, the inference code of the LLM, how it takes that input from the pre-processing policy and passes it to the LLM, and the LLM then generates the tool calls that are necessary, and in the post-processing policy, we are calling these individual tools, basically performing the tool calling features of the LLMs, and sending the final mail to the individual people. So this whole tutorial is more about how this pre-processing and post-processing code from the author, right, when they give their own LLM model, how they are used to construct a workflow kind of pipeline. But if you want to generate your own policies, right, and either apart from the author's policies or in addition to the author's policies, so that is available in this particular tutorial, which explains how these policies also can be swappable. Of course, you can modify these policies yourself as well, but as a modular and neat structure, we can also have these policies outside the model, which I will show in this particular tutorial. So in this tutorial, also it's pretty much similar to the previous tutorial we saw, but here we are going to see how to use the VDAG concept to run this particular block and the policies. So here the policies are swappable also, like we can have your own custom policies or the author's policies, or any person who comes up with their own policies can be added as part of this LLM model, right? So the tutorial overview is same. Like the task is to automate this candidate, the recruitment process, and the policies are pretty much the same that as we discussed in the previous one. The how we are constructing the VDAG is what is a major differentiating factor, and we will see how we are going to construct the VDAG spec and how to run this particular tutorial as a VDAG, right? How to run this automation as a VDAG. That's what we'll be seeing in this tutorial. And so the task is same, to automate the recruitment process, and the only difference here is this particular policies, right? The pre-processing policy and the post-processing policy role, they are now part of the VDAG, unlike what we saw in the previous tutorial. So they are now part of the VDAG, and again, these policies are the type of these policies are same like the previous tutorial. They are type 1 policies, and within the post-processing policy, it calls the tools again, right? In the same way as in the previous tutorial. And those tools are nothing but type 3 policies. So that's why you can see the difference in the flow diagram here, that the resumes are, the zip file is passed to the VDAG block level pre-processing policy, right? Not the author's block, only block pre-processing policy. Similarly, the VDAG block level post-processing policy is also there, right? And so the codes are pretty much the same like we saw in the previous tutorial. There is not much big difference. So let me go to the allocator JSON. So in the previous tutorial, if you remember, we saw that we passed the pre-processing and post-processing policy as part of the allocation JSON here, right? The pre-processing and post-processing policy. But in this VDAG tutorial, we can also pass that, we can also pass our own pre and post-processing policies as part of the block. But for this tutorial, to show the difference between this and the previous technique, I have kept the, I have not added the pre and post-processing policies here. Instead, I will be adding it as part of the VDAG. So the VDAG spec, right, now it goes like this. So we have the VDAG name, the VDAG version, discovery tags and all, and we have a single node VDAG, which is nothing but we are passing the same Llama 4 Scout model, and the node type is block, and we are passing the those pre-processing policies like this. It is part of this particular node, particular block, and it is a pre-processing policy rule. And similarly, we have this post-processing policy rule, right? So this is a VDAG spec, unlike the block spec we saw earlier. And I'm also defining the graph structure as the input will be whatever the user sends, and the output will be the output of that particular the recruitment node itself, right? So let me, the node label is recruitment node. That's why we are using that in the graph, right? And so before running this, let's also see one more scenario, basically how the inference flow happens. So given the request, the VDAG controller receives a request and pass it to the first node, the block of the graph. And so here we are giving the block as a Llama 4 Scout 17B block. So it uses that block, and it will first the first policy that will be executed is the VDAG's pre-processing, this particular block's pre-processing, right, which we have defined here. As this block is part of the VDAG. That's what is important to remember. Then, if at all we have defined any author's block pre-processing, right, which is nothing but as part of the allocation JSON. So then that will be called, right? In this case, since it is empty, it will be simply passing to the next step of LLM invocation, where the collected candidates data are passed to the LLM. Then if there is any author's block post-processing, which is a part of the allocation JSON, then that will be called. Again, in this tutorial, we have kept it as empty. Then it will be, then the its output will be passed to the VDAG's block post-processing, right? Which is what we have defined here. right? And in this case, the policy is same as we saw in the previous tutorial. It is nothing but the recruitment post-processing policy, right? Then towards the end, we should get the final response of the structured output that we have. So the pre-processing policy is recruitment pre-processing on OOS table. Post-processing policy is recruitment post-processing on OOS table. Now let's do the actual VDAG level inference. So here I have the create VDAG URL, and I'm using the post request to basically create this particular VDAG, and we are passing this recruitment VDAG spec that we have, right? So that we have defined here. Oh, sorry, I have to execute this cell. Yeah. Let me run this cell. Yeah, now the VDAG URI is created. VDAG is created. Now let us also, to make sure that this particular VDAG exists, let me check its, yeah, it is present in the registry. You can see the head block is this and the tail is this. So it has the graph compiled. It also has a post-processing policy and pre-processing rule that we have defined. Right, now let's create the controller for this. So we are passing the VDAG URI name and we are passing the controller name that we want. The controller is also created. So now we need to get some, the APIs on which the controller details on which we are going to do inference. So let me run this by passing the controller ID here. Yeah, so here I have the API URL 117.3.1.8.7. So this will be the this will be the endpoint on which we will be doing the inference. So again, similar to the previous tutorial, I have the zip file path. It's in the same location as this notebook, and I'm passing the inference URL. So this is where we have to correct this. So it is 35.232.150.117 and a 3.1.8.7, which is what we have here as well. And so we are the query is the same like we saw in the previous tutorial. A computer vision engineer hiring for a senior computer vision engineer with the required experience and the frameworks that we want. Again, the same instruction for the LLM: initiate background check for qualified candidates, send appropriate follow-up communication. Right, and here we are passing the binary data, extracting the zip file and not extract. So I'm sorry, we are reading the binary file and we are reading the zip file to get the binary data and base64 encoding and sending it in the REST API. So the structure goes like this: the model that we want to do inference, the session ID. So let me give a different session ID, the sequence number, the mode is chat, and this particular message will be passed, right? This particular message. And the file's structure is the metadata contains the file name and the zip file path, and it's actually the file name here, and the size contains the file size that we get here, right? The binary file size, and the file data, the base 64 encode data also we are passing, and we are doing a request.post to with this inference URL. So let me run this now, and I will also show the logs in the KH dashboard. So successfully read, and let me show the log. So this is the Llama 4 Scout. Now again, this is loaded with the new allocation JSON that I showed you, which doesn't have any pre and post processing policies in the block level, but it has a pre and post processing policy in the VDAC level, which is nothing like which is like our custom pre and post processing policies apart from the author's policies. So here you can see the same pre-processing policy is extracting the content from the resumes that we have, right? And the session ID is 135. Yeah, now you can see that the LLM has constructed its output: Anjali Rao, Priya Singh, Rohan Mehta, Vikram Reddy, and it has come up with the execution plan of calling the tools like this: background check batch, generic background check policy rule URI, which we have passed, and then those are nothing but the LLM's output. and it is giving its own explanation that Aditya Sharma is not included in the background check, has less than 6 years of experience, right? Which is what we saw in the previous request as well when we were running it as a block. And here you can see the post-processing block is extracting the JSON, and it is doing the usual steps of mailing and all, right? It will do a background check, and then it will pass the communication as to whether who is selected or not, right? So this is pretty much the same. I'll just you can see that the particular mail also we have received. So this concludes this tutorial. So in as a takeaway, we can use these kind of policies. If they are authors policies, we can add those policies as part of the blocks pre-processing and post-processing policy like this, and then create a workflow like this, right? And using the type 3 policies of the AOS ecosystem, we can implement a tool calling facility also in this post-processing. And if we want to have our custom policies, but we want to use the authors model, then as per this tutorial, we can construct a VDAC and add the policies as a part of VDAC. As part of the blocks policies as per this particular VDAC spec, right? So these are two different ways which we can run the block code with its own custom policies, right? That's pretty much it on this tutorial. Thank you.